Hello viewers, in this video I'm going to explain about the Edaphic factor. Okay, the Edaphic factor is nothing but the soil factor. It means the effects of all the factors which are related to the soil on the vegetation of plants and also animals. Okay, first I will explain about introduction of Edaphic factor. Here, as you all know about the Earth, Earth is a cooled, spherical, solid planet of solar system which rotates on its axis and revolves around the sun at certain distances. As you all studied about the Earth in your previous classes. Here, in this video, we are going to see about that soil factor. That the solid component of Earth is called as lithosphere. Okay, here the soil is the outermost layer of lithosphere. Generally, the lithosphere contains three parts: crust, mantle, and core. Crust is the outer layer, mantle is the middle layer, core is the bottom layer in the lithosphere. Here, the soil is outer surface layer of the crust, layer of lithosphere. And coming to the word soil, this word derived from the Latin word that is solum. In Latin language, the solum means earthy material in which plants can grow. And the science which can deals with the study of soil is called as soil science or pedology or edaphology. The study of the soil science, pedology or edaphology significant for us due to various reasons. We can understand that about the agriculture process, and we can understand the all the factors which are shows their effect on the plant growth, and also it is possible to know about the actions or the reactions of pesticides or growth hormones and also soil microorganisms on the plant growth. Okay, now we'll see about the soil. Here, the soil is the superficial, weathered, and also humus containing layer of the earth in which the plants can sustain their lives. And also, it contains numerous living organisms and their death remains. Soil contains all living organisms and their death remains. It can provide the anchorage to the plants, and also soil is the storehouse of the plant nutrients and moisture. According to Skimper's second law, a soil determines the local distribution of plants either directly or in relation to the other factors. And here another scientist, Warming, classified the plants on the basis of soil in which they can grow. They are lithophytes, chasmophytes, samnophytes, halophytes, xerophytes. The plants which can grow on the rocks comes under lithophytes, and the plants which can grow on the rock fishes Those plants are comes under chasmophytes. And the plants which can grow on the sandy soils, these plants are comes under samnophytes. And remaining two are halophytes and xerophytes. As you all know about the halophytes and xerophytes, the plants which can grow on the saline soils are known as halophytes. And the plants which can grow on the acidic soil or xeric habitats, these plants are comes under xerophytes. Okay, these are the different types of plant categories based on the soil type. Okay, then next we'll see the composition of soil. Generally, a soil contains four parts. These four parts are I listed here in this slide: mineral matter, organic matter, water, and air. And a good fertile garden or a good fertile farm soil contains these four parts in this following ratio: mineral matter 40%, organic matter 10%, soil water 25%, and the remaining 25% is filled by soil air. Okay, if a land area contains all these four parts in these ratios, in that case only we have to call that land area as a fertile land or fertile farm or fertile garden. Okay, now first we'll see about mineral matter. Mineral matter of soil occurs in the form of particles. These particles are irregular in size and shape, so that they cannot be patched tightly. Instead, they enclose numerous space for the circulation of water and air. And the texture of soil is a great importance in determining the relation of place, because the texture of soil determines the water holding capacity of soil, and also it can determines the aeration of the soil, and also it can determines to some extent that is availability of water for absorption by the roots of the plant. Depending on the size of mineral particles have been 7 different names by International Society of Soil Science. Those 7 names are I listed here in this slide. The first one is the stones, coarse gravel, fine gravel, coarse sand, fine sand, silt, clay. Now we'll see the size of all these soil particles. Stones size in between 10 mm to 100 mm. Coarse gravel size in between 5 mm to 10 mm. Fine gravel size 5 mm to 2 mm. Coarse sand size 2 mm to 0.2 mm. Fine sand size 0.2 mm to 0.02 mm. Silt particle size 0.02 mm to 0.002 mm. And the remaining 7th one, that is a clay, the clay particle size less than 0.002 mm. Out of all these soil particles, sand and gravel provides physical support to the plant. Okay, gravel and sand can provide to a physical support to the plant, and clay, silt determines the water holding capacity and nutrient availability of the soil. And these clay, sand, silt form most of the mineral matter of the soil. Okay, now we'll see the character or properties of these soil particles: sand, silt, clay particles, and also loam soil. Yeah, the sand particles are larger in size and they expose a very little surface area. And these particles enclose large pore space. And water holding capacity is very little in compared to those remaining mineral matter. And next, silt particles become plastic in nature when it is in wet condition, and it turns like a talcum or flour or powder when it is in dry condition. And the next one is the clay. The clay particles are very small particles and the size reaching of colloids. They expose a large surface area. They hold cations over their surface and these are chemically very active. And these clay particles enclose fine pore space which get filled with the water and exclusion of air. And like silt, clay turns into plastic in nature when it is in wet condition, and uh, and also it swells on wetting and shrinks on drying, and this strain is associated with scratching because of less aeration, and the total clay soil are less preferred for the plant growth. Next soil is a loam soil. The loam soil possesses a good properties both clay and sand soils as both the types of particles are present in sufficient amounts. In these loam soils, some of the particles are large while functioning as a nuclei, around which smaller soil particles collected to form water stable aggregates. This process is called as flocculation, and the soil aggregates provide the both aeration and light water holding capacity. They allows passage of roots through the large interspace and it is the best soil for the plant growth. Here, depending upon the strength of their constituents, the loam soil are divided into sandy loam, clay loam, and silt loam.